I'm going to help you set up binder page 144 so you can take notes on the video that's following my instruction. The big picture is that a force is an interaction between two objects. Some people define it as a push or a pull. Both are correct. You're going to need a pen or a pencil and a ruler or a straight edge to get this chart in better shape so that it goes along with the video. You are going to need to draw in a couple of these lines yourself because there's not enough rows in the chart. So if you could please split the first row in half by drawing in your own line where I'm putting the highlight. And if you could also do another split of the second row, that will help us have enough rows for all the forces we're going to talk about. We're going to talk about 7 forces. The first one he'll discuss in the video is gravity. Make sure as you watch the video, you write down the symbol for force of gravity, the definition, and the example. If he's going too fast, hit pause, go back. Number 2, he'll talk about force normal. For this video, he talks about tension as number 3. So you don't have to write anything for that, but do pay attention to the video and look down at the bottom of your chart where it says force tension. Then you'll be picking up again with you doing the writing for the 4th one he's going to discuss, the spring force, and then force of friction, air resistance, or the force of air molecules against a moving object, and then finally the most common one we're going to use, force applied, the true push or pull you can easily see. So it would be good to hit pause right now so that you can get your chart organized before the next part of the video. I forgot to mention, cross out this very last column called force diagram. We're not going to use that for this video.
So here's why thinking in terms of interactions is so important. A force is a push or pull that acts upon the object in question that results from its interaction with the other objects in its surroundings. The important ideas here are, first, a force is a push or pull, and second, a force results from an interaction. Now when it comes to interactions, there's 2 types. There's contact interactions, and that's when the object in question is touching other objects in its surroundings. And then there's field interactions, which are somewhat the opposite. They result even though there's no contact with the object in the surroundings. So let's begin by talking about those contact force interactions. That's when the object in question is touching another object in its surroundings, and that's as a result of that contact, there's a push or pull. There's 6 types of these forces. We call them normal force, tension, spring, air resistance, friction, and applied. And we'll talk about these individually as we go through this presentation. The second type of force, big large category of force, is called field forces. Field forces result even when there's no contact between the object in question and the secondary external object in the surroundings that's putting the push or pull on it. And examples of these types of forces are gravity, magnetic, and electrostatic. You don't have to be touching the earth to experience a gravity force. 2 magnets don't have to be touching to exert a push or pull on one another. And 2 charged objects don't have to be touching in order to exert an electrostatic push or pull on one another. The first force we'll talk about is the gravity force. We represent it by the symbol F, grav. This is a non-contact force that acts between any 2 objects with mass. It always results because masses mutually attract one another. This idea is called universal gravitation. It'll be a topic of several videos in future series of our video tutorial. Gravity forces are most significant when one or both of the objects are very massive, like the Earth. So here's an example of a gravity force. The Earth pulls downwards upon any object that is near it. Now let's talk about some contact forces. The first is normal force. We represent it by the symbol F, norm. This is the force that results when an object presses against another object in its surrounding. An example is a person stands on the floor. The floor pushes up on the person with a normal force. As the person does stand on the floor, the feet of the person and the floor are pressed together, and that results in a normal force. Second example is a book is at rest on a table. When the book rests on the table pushes up on the book with a normal force. This results because the book is pressing against the table and the table against the book. That results in this normal force. In both of these situations, the normal force acts from below because the surface pressing on the object is below the object. But it doesn't have to happen that way, nor does there have to be just one normal force acting upon an object. Here's another example of a normal force. If you look at the physics book, it's pressing against the table and it's pressing against a chemistry book from above. This results in two normal forces. The table pushes up on the physics book, and the chemistry book pushes down on the physics book. We call it the normal force because the normal force acts perpendicular to the surface, and as such, we borrow a word from math class, normal, which means perpendicular to. Our next contact force is called tension force. This is a force transmitted through a string, a rope, a cable, or a wire that's pulled tight. We can use the symbol FTENS for tension force. Here's an example. A box hangs from the ceiling by a cable. In such a situation, the cable exerts an upward tension force on the box. As a second example, a dog is pulled by a dog chain. In such an example, the chain exerts a tension force upon the dog. The tension forces are always directed in a direction parallel to the chain or the cable or the wire or the string. Spring forces, denoted by the symbol F spring, are sometimes confused with tension forces. Tension forces result from strings, wires, cables, chains, etc., but a spring force results when there's a stretched or compressed spring. Such a spring exerts the so-called spring force upon the objects that it's attached to. Here's an example in the picture. A mass is suspended from the ceiling by a spring. The spring exerts an upward pull upon the mass that we call F spring. Friction force is also a contact force. We denote it by the symbol F frict. This is the force between two surfaces that are sliding, or at least attempting to slide, across each other. An example is a truck skids to a stop along a road. In this case, friction exerts a backward force upon the truck. Or a baseball player slides across the infield dirt. In this situation, there's a force between the infield surface, and the player's uniform. It's a backwards friction force. In fact, friction usually opposes the motion of sliding objects. Friction will be at the topic of another video later in this video tutorial series. Air resistance is another contact force that results from objects that move through air. As an object moves through air, it collides with air particles, and the cumulative effect of all these collisions is it results in a force which we call air resistance and represent it by the symbol F air. A skydiver falling is one example of air resistance. As the skydiver falls, air resistance acts upwards upon the skydiver. But the object doesn't have to be in mid-air in order to encounter air resistance. It can be moving along the ground, and as it moves along the ground, it still collides with air particles. For example, a truck moving at high speed down the roadway. As it does, air resistance acts backwards on the truck. Air resistance tends to be greatest for high-speed objects that have very poor aerodynamics. Our final contact force is referred to as the applied force. It's the force exerted upon an object by a person pushing or pulling on that object. An example would be a worker who pushes a crate up a hill or even along a horizontal surface. There is an applied force acting upon the crate by the person. This force is usually a catch-all type of force to account for any other force that hasn't been covered by the other force types. Many people would refer to this force as a normal force instead of an applied force. After all, when you think about it, it's the force that results from two objects pressing together.